Okay, good afternoon to all. So formally we are starting our lecture 3, right? In last lecture we have discussed about the subsurface soil explorations. Actually we started the uh, topic that subsurface soil explorations. In last class we discussed about why do you need the subsurface soil explorations. There are some reasons, being a foundation engineer, that the informations we needed so we can get it from the explorations data. An overview of subsurface explorations, that this is a plan, like overall plan how we are going to conduct the exploration. And this is some preliminary data uh, before going for a test, so we can decide how much depth we are planning to go, or how much depth we, or where we actually need to stop our testing. And this is the same continuation of the depth of boring based on the um, example of 30-meter wide buildings.
Okay.
So then we also uh, discuss about the depth of boring for different types of structures. These are general guideline, like if it is a steel or narrow concrete buildings, and also for the heavy and the wider concrete buildings. How can you find out the depth of boring?
Sir,
Yes.
narrow concrete building is still a narrow concrete building, sir. We consider it, sir, one or two story concrete building or more than that.
Which one?
Sir, first one, sir, narrow concrete building, sir. Steel or narrow.
Yes.
Sir, we consider it as a one or two story building or more than that.
It is up to you. This S is the number of stories. You just put the value of S here. If number of stories 5, okay, you put the story there 5.
Sir, heavy steel or wide concrete building, sir, for there, how much stories we consider, sir? More than 10 or more than 20 or more than 50 stories or narrow concrete or for steel we can use 15 or
It's
20
up to
street for
you.
there
It's
also.
up to the project. I think you do not understand what is narrow concrete building and what is wide concrete building. That's why you're asking. Number of stories not fixed. Suppose you have a project for 6 story. You just put the value of S is 6. So now you need to go for the narrower, wider. If it is rectangular and like aspect ratio is very good, seems to be rectangular, you consider the wider. So you look into the BNBC, or you look into the standard code, which one they consider the narrow building for concrete, and which dimension they consider for the wider, right?
Yes, sir.
So on that case, if it is a 10-story residential building, you put the value of S there. If it is 5-story, you put the value of S 5. So, I don't know who asked me the question about the storage. Storage is not fixed. Suppose you want to build a building for 3-story, so okay, you consider 3. If you want to build a building for 10-story, okay, you consider T. If you want to consider a building for 15-story, even 20-story, you consider S as a 20. What is the problem?
Okay.
You understand?
Yes, sir. Now I understand.
Yes, sir.
Okay. So, and based on the aspect ratio of the land, like the width versus length, uh, or length versus width, so there are also some limitations. How much is the maximum story you can consider? And this is the just another way to find out the maximum spacing, but make sure that you are covering the center and the corner of the project. Okay. So today we'll start our regular lecture from these methods of soil boring. Okay, so we know if you want to do the test or soil test, first of all we need to dig the soil in our desired depth, right? So that's why we need to make a bore, or we need to make a hole in the soil, and we go for the testing, and we take the sample based on our desired depth. So usually there are many more boring methods, but here we'll discuss 4 boring methods. mainly these four. Auger boring. Okay, so you can see there are some devices for the auger boring. Okay, so we will go details on this individual boring methods. Then wash boring. So by seeing the name, that is wash boring, you can see, okay, it might be related something with the water and washing, right? And percussion drilling. So this is one of the drilling where you will use the drilling bit. Another was the rotary drilling. So these four will cover in this course. Okay, there are other also. So mainly we'll try to cover these four popular boring methods. So do you know what is boring actually?
So crack into the
Digging the
soil.
soil.
Exactly. So digging the soil,
Digging the soil.
digging the soil that you. So here you can see some of the devices or the equipments for the auger boring, right? So these are mostly the hand auger boring. You can execute by your hand, and there are some also mechanical or power driven also. So we'll see later. And this is the example of wash boring, where you can see they are pumping water right here, and here some amount of water is adding with the clay, and it is flowing outside with this one here in the settling tank. Anyway, so we'll discuss also later. And percussion drilling, here we can see there is a drilling bit, and it is a little bit heavier. So by lifting up, first it lifting up, then it make a free fall, so it hits the ground, and this way it make the drilling. Okay, it make the boring. And this is the rotary drilling. So rotary drilling, there is a drilling bit, so it rotates. Okay, it rotates mechanically. So you can see so it rotates and goes down, and the the digging particles come out with this pipe and deposit here. So I'll show you a video also later. So these four kinds of methods or four methods of boring we'll see. Okay, so if we start with the auger boring, so this is one of the simplest method of making the borehole. So usually two types of auger boring we can see, or auger we'll see. That is in case of hand one, that is the post hole and the helical auger. So you can see this picture A, this is the post hole auger, and this is the helical auger. Maybe you can see in the carpentry mistry also using this helical auger while they drill the wood, right? Do you see this kind of activity
Yes,
in your
sir.
house with the carpentry mistry,
Yes,
right?
sir.
Okay. So this is all about the hand auger. So hand auger cannot use 3 to 5 meter, because if it is going more depth, you need more energy. So it is not possible to go for more with the hand. So this is difficult. And soil exploration work on some highways and small structures can be done with this hand augers method. So as I said, auger boring can do the borehole up to 3 to 5 meter. That is the hand one, if you want to use your hand energy on that. So usually for the small structure which doesn't need the deeper soil explorations, that time you can do, or for the highways also, right? Okay. And portable power driven helical augers, actually you can go for more deeper. So you can generate some power by using the mechanical device or some electrical device to generate more power. So then you can go for more deeper. Okay, so here you can see the drill of the portable power driven helical augers. Can you see this?
Yes, sir.
So you can connect this bit on the uh, rod, and if you just rotate with the power, so it will go. And sample operands from such boring are highly disturbed. So normally we'll also check about the sample or sampling technique. So sample are usually two types. disturbed and undisturbed. So these kind of samples are highly disturbed. So I'll also discuss in details what is disturbed soil and undisturbed sampling of soil. And power continuous flight augers are probably the most common method used advancing of borehole. So normally this is one of the popular one that we use, the power one, and the tip of the auger is attached to the cutter head. So this is the cutter head and tip of the auger. Suppose if you consider uh, a rod here, if you connect this one, okay, so then that is the tip we are considering. Okay, so some more information about that. That auger can be solid, power driven. This is the power driven auger, right? Can you see the picture?
Yes, sir.
Yes, sir.
Okay, so this is actually the power driven auger. This one, you can see the bit. So here you might have solid steam auger or you might have hollow steam auger. Okay, so in case of solid steam, you cannot take the sample, because suppose you want to do the soil test. After 5 meter, you want to take the sample, and then after 2 meter, you want to take the soil sample. Then after 2 meters, you want to take the soil samples. So in that case, if you use the solid one, that time you cannot take the sample, right? So you need another technique to collect the sample. Maybe for the solid stem, they usually use the aspirate test technique. So we'll also discuss today what is aspirate test, standard penetration test. And if you are using the hollow stem auger, do not have to be remove frequently the bit, right? And you can also take the sample, the pilot assembly and center rod are removed. So here you can see, here is a center rod. Can you see? So by removing this pilot assembly and the center rod, you can take the sample. If you remove this portion, so this portion will be hollow, right?
Yes, sir.
Inside this.
Yes,
So
sir.
this portion will be hollow. So if this portion is hollow, soil will be insert here, and that portion you can consider as a soil sample. Are you getting the point?
Yes, sir.
While
Yes,
it is
sir.
hollow, you just remove the center rod. Okay. So then this portion will make
Okay.
some free space, and at which depth you want to take the sample. Suppose you are going to do the borehole like this. Okay, suppose after 5 meter you want to take sample. So this is the 5 meter locations. Okay, this is the 5 meter locations, and you want a sample after that. So what you did, while it is in 5 meter, you remove the center rod. You take it off and you remove the center rod and you start it again here. Okay, so suppose after going there, so you're getting the sample. So similarly after 10 meter, suppose at 10 meter, again you want to take the sample. So again you go you take it up and you remove the center rod, and from here you start again boring. So some sort of soil will insert in the air, right? So this way you can take the sample easily. So soil sampler is then inserted through the hollow stem of the auger column. So if you remove it and just soil sampler input here, then you will get the sample here. Is that clear to all now?
Yes, sir. Yes, sir.
Okay. So this is actually about the auger boring. Wash boring, it is most popular, maybe you have seen from your childhood in Bangladesh, or maybe in your village also. Sometimes you see, while also people do some deep tube welling, that time also they use even shallow
Yes,
tube
sir.
wells, they also
Yes,
Yes,
use
sir.
sir.
this pumping, right?
Yes, sir.
Yes, sir.
Pumping,
By this
Yeah,
submersible type.
yeah, you have seen it maybe in your village, even in the side also. So another method, that is the easy methods. A casing about 2 to 3 meter long is driven into the ground. So initially, after initial driven 2 to 3 meter casing, usually we insert in the ground. Okay. The soil inside the casing is then removed by means of a chopping bit attached to a drill rod. Okay, then we attach a drill rod there, and water is forced through the drill rod and exit at a very high velocity. Suppose this one is cutting some soil here, right? Suppose this bit, you can see the sharp bit here.
Yes, sir.
So it is cutting the soil here, and you are pressuring the water here. So what happening? The water and this cutting soil making a slurry or making a fluid type kind of materials, right?
Yes, sir.
And while you pressurize more water here, what is going to happen here? There will be some upward force from the water, and you can see it is going here, right?
Yes, sir.
So you are putting water from this way, right? And it is going there. Is that clear? How
Yes,
it
sir.
is like taking off the
Yes,
slurry
sir.
of the borehole, and you continuously give the pressure here. You make it up. Once you go up and you release it, right? And this cutting bit or this is very sharp, right? So this sharp bit is hitting to the ground and making some loose it is losing the soil base, and water is coming with the high force, and it is take away the soil particle. Okay, is that okay? Clear?
Yes.
Okay, sir. Okay, sir.
Okay, response with me, otherwise I feel that okay, you are not listening me, my internet connection is lost, something like that. Okay, so you can see the water and the chopped soil particles raise into the drill hole and overflow at the top of the casing. That is the T connections. Here you can see the wash water is collected in a container. So you can see there is a container, it settles down, the particles goes down, then they dump it some other way. Washboarding are rarely used now in developed countries. So normally in developed countries they are not no longer use it due to the environmental concern actually. Okay, so now come to the rotary drilling. So we already have the introduction with the auger boring method and wash boring. So now come to the rotary drilling. So before I discuss this rotary drilling, I want to show you one video, animation video that might be helpful for you. Okay, so now
Explain
here
very
you can
slowly,
see this
sir.
is actually we call rotary drilling. So the drilling bit is going downward, right? And this is the casing is coming up, so it can hold the uh, soil that is cutting down, right? So the black one, so it is just taking the soil that is coming from the ground, and this yellow pipe or rod, it is going downward gradually. So it is cutting the soil into the ground, and the cutting soil is coming through this black pipe. Can you see?
Yes, sir.
Yes, sir.
Okay, so this is usually the process of making drilling by making borehole with the rotary drilling. You can see that the bead is moving, right, rotating, and it is cutting the soil, and it is gradually taking all the soil inside the drill bit, right, and it
Yes.
is taking up towards the ground, above the ground, and finally it will dispose in a land where you want to dispose, and it is going down more. Okay, so you can see now it is ultimate level. So if you want to go more, so that time you can add the rod here, right? And
Yes,
here
sir.
you can see they are just removing their rod. So here they just put a casing here because uh, they might insert the rod reinforcement bar. Maybe they will do the piling here, so they will insert the reinforcement casing here. There are another options also to use the bentonite to make a layer that the soil does not collapse into the hole. I will discuss also. So the both way you can do. You can give a casing, and or you can also do the use the bentonite with the water, make a slurry that the surrounding soil does not crave in. Okay, so they are just removing the soil that was inside the rod. Okay, so this is actually the regular process of rotary. So different kinds of machines may have different kinds of uh, facilities. So now they are just the same machine has the options to pull up the casing, reinforcement casing, and they are just inserting, and now they will just pour the concrete. Okay, so this is one of the example how they are making the rotary drill. Now is it clear to you?
Yes, sir.
Yes, sir.
Okay, so I think
Yes, sir.
some video tutorial might help you sometime. Now we can see that the rotary drilling usually rotates with the a cutter, right? And it make the hole inside the ground. So a rapidly rotating drilling bit attached to the bottom of the drill rods cut and grind the soil, right? It is cutting and grind, making the smaller pieces. Okay, and rotary drilling can use in sand, clay, rock. So even for the hard soil, it is usually used the rotary drilling one. And water and drilling mud is forced down the drilling rods to the bits, and the return flow forces the cutting to the surface. Actually, what happened while it is cutting the mud or soil, water and drilling mud, we call it sometimes water with the bentonite, or drilling mud, like mixing water with the bentonite, that things we uh, add into it, this borehole, and we force it down. Okay, so through the drilling rod to the bits, and then the return flow force the cutting of the surface. And in case of it is it is returning with the cutting forces. And boreholes 50 to 203 mm diameters can easily perform. That means higher diameter of borehole you can do. So nowadays you might see in the project of uh, what is called, that is the 300 feet, or some of the very big projects inside Dhaka. So they are using this kind of drilling machine. Maybe you might see. Do you see this kind of machine?
Yes, sir.
Yes, sir. Yes, sir.
Do you see this kind of machine?
No, sir.
No, sir.
You have not seen this kind of machine yet. Okay,
No,
you
sir.
better go to the 300 feet road. That is we call, what is market we call it is, who is nearby Khilket or that area, Bosundara.
Yes, sir. We see it, sir. Just forget it, sir. We see it in sir, Abdullahpur and Airport Highway, sir.
Okay,
Uh,
so this kind of
that
machine you will
rural
find.
process.
So they
Project
produce
completion.
less waste. Okay.
Yes, sir.
Okay, the drilling mud is a slurry of water and bentonite. You see what is bentonite? This is kind of chemical which does not allow the surface soil. Suppose this soil, okay, this soil may be crave in, right? It has a tendency to crave in. So if you apply this bentonite, it will not crave in. It will be stable here. So generally it is used when the soil that is encountered is likely to crave in. So whenever it has a chance to collapse to the bottom, right, or it covers the hole, something like that. So when soil samples are needed, the drilling rod is raised and the drilling bit is replaced by a sampler. suppose you want to have a sample from here, right? You drill it up to that. So now you want to have a sample, soil sample for the testing. So you remove the drill bit and you use the sampler here, and you take the sample here. Is that clear?
Yes.
Sir.
Yes, sir.
Okay. Okay. So with the environmental issue, actually, the drilling applications, rotary drilling with air is becoming more common. So uh, instead of giving this water and slurry, so nowadays air drilling is getting the priority with the air pressure. And one information about this one, that is the bentonite. So drilling mud is a slurry of bentonite water, right? We already seen last slide. So the drilling fluid causes a stabilizing effect to the borehole, partly due to the higher specific gravity as compared with water, and partly due formation of mud cake on the side of the borehole. Suppose when you are like working with the borehole, if you apply this bentonite slurry, so what happening, it making a artificial layer that which does not allow soil to fall or cave in, right? If there is a loose sand or very sandy sand, right, what is the tendency of this kind of sand? Whenever just having some contact with water or having some moisture, it try to flow away, right, and it try to cave in. So this kind of tendency it has. But if you use the bentonite, so that time this tendency you will find is gone. And as the stabilizing effect is imparted by this drilling fluid, no casing is required if drilling fluid is used. So that time usually you don't have to use the casing if you still have the loose sand even. Okay, so for this one also I can give you one demo video. It will make your concept maybe more clear. Can you see the video
Yes, sir. You can see.
video
Yes,
guys?
sir.
Yes, sir. Yes, sir.
Yes, sir. Yes.
So have a look. This guy is trying to show you how bentonite is working. So first of all, he is trying to pulling insert a suppose a pipe into a sandy soil, right? In this beaker, he is getting and he's pulling some pouring some water into this sandy soil, and also inside the
Fine.
pipe where you usually do the drilling, right? So now what is he going to do? Like he will take it off. He will just take it off the pipe. Now you'll see what is the scenario. And okay, if he removes the water from the soil, extra water from the soil, now you can see all the soil cave in. You see the borehole fill up with the loose soil, right? Can you see the phenomena?
Yes, sir.
Yes,
Did
sir.
you see the phenomena that all the soil fill up with the, you see the borehole fill ups, almost it fill ups with the loose soil, right?
Yes, sir.
Yes, sir.
Yes,
So
sir.
now he is going to apply the bentonite to
Bentonite.
show the same activity. You will use the same quality, same standard of soil, that is the sandy soil, with the same diameter and other specification of the borehole. Maybe you consider this is kind of a drilling rod of bore, and he is going to apply now bentonite. So in the beginning, he just apply some of bentonite in the top and some of inside the drill, right? So now what he is going to do is slowly he will just rotate and slowly he will let the bentonite insert into the surface, and slowly he will remove it. Okay, so now he will pour again the extra bentonite in a separate pot. Okay, so he's just removing the extra bentonite in separate jar. Now hopefully he will show us the scenario of what happened in the borehole. You see what
Yes,
is the
sir.
scenery now? So you see,
Yes, sir.
even though very loose sand does not cave in.
Yes, sir.
So suppose if you are thinking of any
The whole is
pile casting,
thing, sir.
Yeah, diameter of the hole does not change. Everything was in a stable condition. Even you see the sand was very loose with the adding of the water, right?
Yes,
So this is the advantage of using this bentonite.
yes, sir. Is this the material is very costly, sir?
Actually, I'm not aware of it, but may not be costly. I'm not aware of the cost now. May, but most of the rotary drilling project they use the bentonite.
Okay.
Okay, this is a good point. So I'll look into it about the costing, though I never thought of it. Okay, so this is the last drilling boring part of our discussion. Here we will discuss the percussion boring, right? So percussion is a, you can see like kind of advance from the auger. So in auger we just do the drilling, right? So it is also similar, but here we use the beat by using hammering, by using the repeated loading. How it is working? So percussion drilling is an alternative method of advancing a borehole, particularly through hard soil or rock. Usually we can do in the hard soil or in the rock. How? Hole is done by alternatively lifting and dropping a heavy drilling bit. Suppose if you are having this drilling bit, can you see this one, this drilling bit?
Yes, sir.
So by this pulling rope or cable, they are pulling up and they are dropping here. So and it is hitting the ground here. Can you see?
Yes, sir.
And it is making the hole like this way. So that's why they are saying alternatively lifting and dropping a heavy drilling bit which is attached to the lower end of the drilling bit, which is attached to the cable. Okay, and the heavy drilling bit is raised and lower to chop the hard soil. Even for hard soil also we can do. And the chopped soil particles are brought up by circulation of water. So once you have the cutting soil, so you can, or we need to take it off, right? So again we can use the water. We pressurize the water here and we take the slurry out of it, like we have seen the washboarding, right?
Yes, sir.
But in the hard soil it is not possible that cut by only water. So that's why we need the percussion one. And percussion drilling may require casing sometimes. If you have like some loose particle or maybe some other options, you might have to use the casing. You can see they also use the casing. Can you see the casing here? So this four boring methods we have discussed. What are these? Who can tell me now? Anybody? Nobody?
Sir, four boring
Sir,
method, sir.
auger boring, wash boring,
Wash
and
boring.
rotary boring, and percussion boring.
Okay. So I just add the very important and very necessary informations here. So what you can do, you can look into books chapter, you can look into some other reference materials, you can look into YouTube tutorials for like different kinds of boring, right? So each of the boring has like lots of content to discuss, but since we are limited of time, so that's why I just try to give you a very brief and specific on it, specific idea on it. Okay.
Okay, sir.
Sir, I have a question to ask.
Yes. Yeah, you can ask me.
Sir, we here saw four types of vertical boring. Sir, are we going to study or get familiarized with any horizontal boring?
It's the similar technique you can do in the horizontally, just need the different setup of machines. Rotary, this similar of the techniques you can do in the horizontally, but mostly rotary and the auger are using in the horizontal boring. We mostly interested to do the vertical one because we need to know the soil profile or we need to construct the foundations like pile or some other foundations. But those people are like dealing gas line or other water line pipings industry, right?
Yes, sir.
So these people are highly concerned about on that horizontal one. It's okay. Nowadays also like some of the electrical lines, gas lines are like Bangladesh also I can see in the metro rail project the power cables they are like uh, they're transferring through the horizontal drilling, so they use the horizontal drilling to insert the power line cables and other things. Okay. So we have enough rest. Then we can start this lecture. Can you see the type of soil samples lecture?
Yes.
Yes, sir, I can see.
Okay. Where is my cursor? Okay. So now we can see the two types of soil samples. What are these? Disturbed and
Undisturbed.
Undisturbed.
undisturbed. Disturbed and undisturbed. So by watching the name or by seeing the name, we can easily understand what we want to mention here. What is disturbed? Something is not you are looking for, right? Something is
Loose soil, sir.
not you exactly want. Okay, there is some problem. That is we call disturb, right?
Yes, sir.
Yes, sir.
Okay, so in case of sample, soil sample means what? You want to take the sample maybe for 5 meter, 10 meter, or maybe more depth. So what you want? You exactly want that after 5 meters, what is the soil status, or in the soil strata, what is the condition of soil? Exactly same condition soil you are going to collect. That is your intention, right?
Yes, sir.
Because after
Yes, sir.
suppose if I consider 10-meter depth, after 10-meter depth, what is the soil condition, right? Soil moisture conditions, soil permeability conditions, every conditions of the soil properties, whatever it is under 10 meter, the soil sample you want exactly like this, right? So if you find something like this, right, that time you call it undisturbed. But if you cannot have it, that time you call it disturbed. But how much disturbed or how much problem or how much you'll consider for your testing, that is also the questions. You understand? Because it is not possible to maintain 100% accuracy that after 10-meter depth, what it is the condition of soil, exactly same condition of soil I can collect. This is not possible, right?
Yes, sir.
Yes,
Okay.
sir.
So based on some issue, we classify disturbed and undisturbed. So what are the disturbed soils we can do? If it is a disturbed soil but a representative, disturbed but what? A representative, this is important term. Disturbed but representative. The soil sample is disturbed but still we can do something with it. Okay. So what we can do, samples can generally be used for the following types of laboratory tests. What are the tests we can do? With this sample, we can do the grain size distribution or grain size analysis, determination of liquid and plastic limit, okay, specific gravity of soil or solid, determination of organic content, what are the content we have in the soil, classification of the soil. So actually classification of the soil and grain size analysis, we can go together, right? Okay. So this kind of uh, test or properties, we can get it either disturbed or undisturbed, doesn't matter. Okay.
Yes, sir.
But if you want to do some important test like consolidation, hydraulic conductivity of soil, shear strength of soil, permeability test of soil, for that you really need undisturbed soil. You understand my point?
Yes, sir.
So now
Yes,
you
sir.
might have questions. Sir, what is disturbed soil and what is undisturbed soil? Is it clear
Yes, sir.
or
Clear.
not? Okay, before I discuss this slide, I'll go back to here. Okay, can you see this slide?
Yes, sir.
Yes, sir.
Yes, sir.
Fluid
This
strong, sir.
part one actually. When the area ratio is 10% or less, the sample is generally is undisturbed. So there are way to find out the area ratio. I'll discuss it later. So if the area ratio is less than 10%, that time we call it undisturbed or equivalence to undisturbed. Otherwise, we call it disturbed. Okay. Even though nearly 10%, we can also call it undisturbed. Okay. But okay, so there are 4 sampling technique. So why we are studying the sampling technique? Because we studied already the borehole, right? So after a certain depth of borehole, we need to collect the sample, right? Suppose here you want to collect a sample. So there are several techniques you want to collect the sample. So you add your sampler here with the drilling rod, you collect the sample. It can be anything, any of these 4, right? It can be split spoon sampler, this one. It can be scraper bucket, this one. It can be thin wall tube, this one. It can be piston sampler. Okay, are you getting my concept?
Yes, sir.
Okay, so any sampler
Yes,
you can
sir.
collect. So what is the target of collecting the sample? Either you will do some laboratory test or you will do some physical test. Okay, so based on your expectation, you will select the sample techniques also. Okay, so can we start with one by one? So we can look into the split spoon sample. What is the meaning of split?
Breaking into half.
Yeah, so it's kind of separation, right? So here you can see, if you can find this one is the real picture of split spoon. You can see this is the cross section of split spoon. Okay, here the split spoon sampler used in the field to obtain soil samples. Generally, what kind of samples?
Disturb samples.
What kind of sample? Disturbed sample.
Disturb samples.
Generally, by split spoon, you will get the disturbed samples, and but still representative. But still representative. That means it still has some standard to maintain the what? Maintain the
Test.
test or do the test that we discuss. Okay.
Yes, sir. Yes, sir.
Okay. So the tool consists of steel driving shoes. That one you can see, steel driving shoes, and the steel tube that is split longitudinally. Okay, so here you can see this is splitting in longitudinally, right? So it's longitudinally in half and a coupling at the top, and in the top you have some coupling rod, right? You connect it here, right? And the coupling connects the sampler to the drill rod. So if it is a drill rod, maybe here you can see this is the drill rod, so it's connected with it. And the standard split tubes has an inside diameter 34.93 mm and outside diameter is 50.8 mm. So that is the usual standard. Okay, but it can be maximized. For the inside diameter can be up to 63.5 and outside diameter can be up to 76.2 meter, sorry, 2 mm. So this is spring core cutter. You just look into this picture. I will come to this point later. So here are 2 pictures you can see here. Left one is unassembled split spoon sampler before just assembling. You can see this is the separation, and that is the sample after getting from the sampling technique. Okay, this is one of the sample, but usually in the sample site or in the field site you cannot touch this sample by open hand or by only free hand, right? So you need a gloves, and this sample should be preserved in such a way it does not contact with the moisture, it does not contact with the atmospheric environment. It better you wrap it as soon as possible to maintain the exact environment what it was in the inside of the ground. Okay,
Sir, but if it's a humid climate, for example, in Bangladesh during summer, so by that time when we remove it, it'll already make contact, right?
No. It is covering, and it covered, and when you just collect it, you will just wrap it from the what is called from the split spoon. You just remove it and you just cover it immediately with the wrapping, plastic wrapping. No problem with that. It is a kind of a few seconds issue. But for this kind of a split spoon, you don't have to go for the some advanced testing, right, which you need the moisture content and other things. But which methods are using for the undisturbed sample, you don't have to open it. It will be inside the samplers, and you directly take the samplers into the lab most of the cases. You understand, David?
Yes, sir.
But for this one, we do not go for the permeability test, we do not go for the moisture content and something. So that's why we can simply deal with it. Okay. So as I said, the degree of disturbance for a soil sample is usually expressed as like this. So that is the formula to calculate the degree of disturbance. So what is the formula? That is d naught square minus di square divided by the di square and multiply with 100. That is, it will give you the in percentage. So what is d naught? D naught is the outside diameter, and di inside diameter, right? So you
Inside
just
diameter.
okay, you
Yes,
just
sir.
put the value. Suppose if you consider the standard split spoon sampler dimension, standard one. So you can see this is the inside, this is the outside, this is the inside. So and you get it around 111.5%, which is highly disturbed, right? So you can see this is highly disturbed. And split spoon sampler generally are taken into
Yes,
intervals
sir.
about 1.5 meter. Normally at 1.5 meter intervals we take the sample, but it up to you. It's a general recommendations. If you find the soil is very uniform with respect to the depth, you can increase this one. Okay, so I will ask the questions. If the regular sample will give you the disturbance of this much, so what are the way that you can reduce the disturbance of these samples? What are the way you can reduce the disturbance?
So reduce the diameter.
It's up to you. Now you can check. I'm not going to tell you this answer now. You check it, you cross check. How you can reduce the disturbance? Or is it possible to reduce the disturbance? If you understand this concept, you should know, right?
Yes, sir.
Okay, so you try it. Okay, so when the materials is when the material in the field is sand, if you find the material is in sand, so particularly fine sand below the water table. Suppose you have the water table already and you find the sample is sand, so that time recovery of the samples by a split spoon sampler may be difficult. So that time is very difficult. Sample is sand and you have still the water existence, right? So it has a chance that the sample will wash away with the water, right, or flow away with the water. So that time what you can do? So in that case, a device such as a spring core catcher may have to be placed inside the split spoon. So in that case, you can use this one, right? Instead of make it open, if you find it is in the water level zone and the sand is or the soil is sandy, so that time here you add this one. You understand?
Yes, sir.
Yes, sir.
So you can add this spring core cutter here. Okay, so this is actually the split spoon sampling methods. Okay, and this is the sampling technique, split spoon. Like what are the way that we collect the sample? So what is the process of collecting this sample? So that kind of test for individual sampling technique we have. Okay, for split spoon, the technique we use, that is we call standard penetration test. What is the name of this?
Sir, standard penetration test.
Standard
Standard
penetration
penetration test.
So by this SPT test, we can collect the split spoon sample. Okay.
Sample.
For
Yes,
other
sir.
samplers, we have other type of testing methods. Okay, so we'll discuss it gradually, but today we'll discuss the standard penetration test. That is, you will find the name is as a SPT test. Maybe in if you just talk about with some engineers like who are like dealing with the piling, soil testing, or making some soil reports, they all often use the SPT test. This is the
I
one of
have
the
experience about this test. Many of
okay.
experience.
This is very good because this is the very common, but in Bangladesh we can say very common method in Bangladesh, and very cost safely technique for us. Okay, so standard penetration test still remain most popular and widely used in the C2 testing technique. So there are so many advantages of this test because it is very easy, though it is giving you disturbed soil, but the conducting process of this test is very easy. I can say super easy. So primarily recommendation for granular soil and other ground conditions. So usually for granular soil you can look into it, and other ground condition were difficult to sample and test in laboratory. So we know that the disturbed sample we usually cannot do the test in the laboratory, right? Some of the test. So that's why
Yes, sir.
where you don't need any laboratory test or it's difficult to conduct the laboratory test, so that time you can also use it. And SPT provide assessment of soil properties. So it will help you to get the soil properties, foundation design parameters, right? So to design a foundations in your RCC, that is, you're designing the foundation, maybe footing. So there you use so many soil parameters, right?
Yes, sir.
Okay, so this kind of parameter also you can find it from SPT test. And liquefaction potential, so liquefaction potential also you can find. So liquefaction is actually very important for earthquake. Okay, so it is widely to accept due to its simplicity. So that what I was discussing actually. That is exactly what I mean. That is, it is very simple. Even 2 or 3 people can conduct the test, and you can give some like regular technician to site and just instruct them. Hopefully they can do it. If 1 or 2 times they can do, and they will be expert on it. It's a very easy technique, low cost, and robustness of driving a sampler into the ground from a bottom of a pre-bored hole. And it's very easy that once you have the bore hole, from that bore hole you can easily collect the sample. Okay, so what are the equipments or tools you needed for this one? That is a standard split spoon sampler that you have seen already, and a drop hammer which is needed around 63.5 kg, and a guiding rod, drilling rig, and diving head that is called anvil. So you can see in this picture actually, right? So this is like they are controlling by with the hand by pulling the rope, and this is the hammer. Can you see? I think I should have another clear picture, maybe. Oh, no, this one. Can you see?
Yes, sir.
Yes, sir.
Okay, so I
Yes, sir.
talked about that you need a hammer, you have a hammer, you have a sampler, right? So this is the sampler you're having. An
Yes, sir.
anvil, you see where the hammer is going to hit on the top of your drilling rod, right? And this is the drilling rod, you can see, right? Suppose you can see this is the total diameter of the borehole. Maybe you are dealing with the borehole, maybe you are doing borehole with the auger, maybe wash boring, maybe rotary, anything, whatever it is. Okay, whatever it is, just drill up to this, suppose. Okay, Maybe you drill, or you might make a borehole up to this, and after that you want to make a sampling, and then you started with the SPT. Is that okay?
Yes, sir.
Okay. Now we can look into the process, how it conducts. So again, I can give you some video tutorial on it. It might be helpful for you. Then I can discuss the what is called. I can discuss the process. It would be very easy for me and also you.
Yes, sir.
So here you can see the simple process. So this is actually one of the example from Thailand. You can see this is the setup of the SPD test, right? Can you see the setup?
Yes, sir.
Okay. And they're going to start. You can see this is the hammering, right? So you already know the amount of weight of the hammer, right? This is 63.3, right? And they are dropping this hammer in a certain distance. So we'll discuss in details
Yes, sir.
after this video
3.5.
tutorial. Okay. Okay. And you see they're counting the numbers. They're counting the numbers.
Yes, sir.
And can you see the 3 marking point here?
Yes, sir.
Can you see these 3 red marking points?
Yes, sir.
Okay.
Yes, sir.
Look into
Yes,
it.
sir.
Okay. Okay, so they first take one data on this sample, and they are going down. Suppose they take data around 5 meter, so now they will take that another data in the maybe 7.5 meter. So they are making a borehole, and they will go to the desired depth. Okay, and after that they will remove this. Okay, so they remove this, and then they insert the sampler. You see, can you see
Yes, sir.
the 3 marking? They insert the sampler. So now they will count the n values. And n values means what? How many number of blow they needed to insert one layer. So they're starting 1, 2, 3, 4, 5. So have a look, 4. After 4, it was crossing their 1 mark, right?
Yes, sir.
Yes, sir.
But fast penetration they do not consider. You see, the fast penetration they do not consider. They will not consider this in the count. Why? Because this is just after the boring. After boring, the soil is highly disturbed, right? So that's why they insert this first 6 inches. Okay, and they are not considering any value. But next, this second and third layer they will consider. So for the next layer, they already hammered once. So that's why you can see in the second step, number of n is 1. Can you see the number?
Yes,
Yes,
sir.
sir.
Okay.
Yes.
Now count. 2, 3, 4, 5. You see, 5 almost finish the second layer, right? 6 still in the second layer. Now, after 6 hammering, that is the SPD value. After 6, they completely inserted the second layer. And when they hammered another, they are having third layer. So that's why they're counting the n value for the third layer. Can you see the value? 1.
Yes, sir.
Okay. 2, 3, 4, 5, 6, 7, 8. So you can see they find the n value 6 plus 8. How much it is? 14. Let's make the average. So this is the way they can calculate the n value. Okay. So can you see my presentation slide?
Yes, sir.
Yes, sir.
Okay. So now life is easy for you. You already see the process. So have a look. Once we decide and we change the sampler, right? That which depth we want to take the sample, we change the we connect the sampler by removing the drilling rod, right? So we remove the drilling tool and we connect the sampler. Then what we do? We use the 63.5 kg of hammer and we consider 750 mm is the height that where it will drop. Are you getting the point? Like from how much distance are we going to drop the hammer? From the rod anvil to 750 mm height. Is that clear?
Yes, sir.
And the rate of blowing, like how frequently you will blow. Like one blow is one and another blow would be 10 minutes later. What your option? No, you have to blow in such a way 30 blows per minute. That means what? Can you say what is the frequency of blowing? 30 blows per minute. So each 2 seconds you need to make one blow. You understand or not?
Yes,
Yes,
sir.
sir. Understood.
Yeah.
Yes, sir.
So each 2 seconds you have to make a one blow. Is that clear?
Yes, sir.
So that
Yes,
is
sir.
the frequency of blowing. How frequently you will blow. And the number of blow of hammer required to drive the depth of 150 mm. Right? So that is 6 inches indirectly is counted. Further it is driven 150 mm and the blows are counted. So you can see the sampler is once again further driven by 150. So 3 times. Once, then second and another 150, right? Then the number of blow recorded. The number of blow recorded for the first time not take into the consideration. I already showed you in the video that first 150 penetration, that first layer penetration, we do not consider the N values. Did we? We did not. Right?
Yes, sir.
So
We did
the
not.
number of blow recorded for last 250 mm intervals are added to the added to give the standard penetration number. So last two values we are adding and that would be our penetration number. Is that okay? So that would be the value of N. So this is a really important value to find out the other parameters of soil. Now by the using of this value N, you can find so many parameters of the soil. These are some general arrangement you can see. I'm not going to discuss this in details. You can see this. One is the general arrangement, and the UK standard hammer system, and the test procedure. And this is maybe one of you, right? You can consider yourself is here. You are pulling this, right? So you just write your name here. Okay. What is your name? You just write your name here. So that is you, and you are doing this test. Now, can you do the test in field?
Yes, sir. You can do.
Maybe.
It's an
Hopefully.
easy one, right? Very easy one. And very often you will find like some people are coming to do the test. So in the beginning they make some wash boring, then they go for one certain depth, then they remove the rod, they connect the sampler, and then they do the hammering testing, and this way they count the N values. So it's very easy. Okay. So these error things and more discussion I will continue from tomorrow. So anyway, so do you have any question with this method? Because this is very important for you, and in your life, if you are going to practice in engineering life, many a times you will face this method. Many a time you need to supervise this method. Many a times you need to deal with the data of this method, of this test, right? This is a very common one in our country.
Yes, sir.
Okay, so thank you guys for joining.
Thank you, sir.
So hope to meet you in next class.